Lesson 27, rational expressions. All right, we know that a ratio can be written as a fraction. Sometimes we have to combine these ratios in addition, and sometimes we have to set them equal to each other, such as in proportions. Today we're going to be talking about algebraic ratios that are in the form of fractions called rational expressions. All right, so rational expressions are algebraic ratios in the form of a fraction. And today we're going to talk about how to combine them. All right, so we're going to be combining rational expressions by addition. All right, so we need to follow a couple steps in doing this. We need to find a common denominator. Once we've found a common denominator, we need to determine new numerators. We're going to distribute and combine like terms. And then finally, we're going to simplify if possible. All right, so 4 steps in solving rational expressions. We need to find a common denominator, determine new numerators, distribute and combine like terms, and then simplify if possible. All right, we're going to do a few examples of this together. The first problem we have is 4 over x plus 6 over x plus a. All right, we're doing 4 over x, which is a ratio, algebraic ratio in the form of a fraction, plus 6 over x plus a, right, another ratio. The first step we want to do is find a common denominator. Most often in these problems, in order to find a common denominator, you're going to have to multiply the 2 denominators together. So our denominator is going to be x times x plus a. Right, if you want to distribute that so that you have x squared plus ax, that would be fine. All right, but we found the common denominator by multiplying the 2 denominators together. That gives me x times x plus a. All right, step 2, we want to determine new numerators. All right, well, I multiplied x times x plus a to give me the new denominator. So I also need to multiply 4 times x plus a to give me the new numerator. Notice that if we were to cancel out x plus a and x plus a, we would have 4 over x, which is what we started with originally. All right, but we're not going to do that for the sake of what we're doing here. All right, now in the second fraction, we multiplied x plus a times x, so we need to multiply 6 times x, and that gives us 6x. All right, so we've determined our new numerators. Now we want to distribute and combine like terms. This is in the numerators. You don't need to distribute the denominator if you don't want to, but definitely distribute the numerators. All right, so if I distribute 4 times x and 4 times a, I'm going to have 4x plus 4a plus 6x, which is our other new numerator. All right, now, are there any terms that can be combined? Yes, 4x and 6x. That gives us 10x plus 4a. And it's all over our denominator of x times x plus a, right? And that is simplifying and solving rational expressions. All right, let's go ahead and look at another example. This one's a little bit more complicated. X plus 2 over x squared plus 4x plus 3 minus 1 over x times x plus 1. All right, now the first thing that we want to do in these problems is to find a common denominator. Alright, if you look at the last problem we did, in order to find the common denominator, we multiplied all of the denominators together. If you look at this problem, and we were to multiply all of the denominators together, we would end up with a huge denominator. So what we want to do is break down any of these denominators or simplify them or factor them if at all possible. Alright, notice the first denominator. This is a trinomial. Okay, we have an x squared term, an x term, and a constant term. Alright, we want to factor this trinomial into two binomials if possible. Alright, so what we learned from last night in lesson 26, we want to go back and see if we can factor. Alright, now we know that our first terms are going to be x because x times x gives me x squared. Alright, now we're looking for a last term that multiplies to give me 3 but adds to give me 4. Okay, of course that's going to be 3 and 1. And since both are positive, both signs in our binomials are going to be positive. Okay, so we've simplified our denominator. Now notice, both denominators now have an x plus 1 term. Alright, so we're going to multiply everything that is represented at least once. Alright, so we have an x plus 1 term, an x plus 3 term, and an x term. Okay, and we don't need this second x plus 1 term because it's already represented in the first denominator. So our total new denominator is going to be x times x plus 3 times x plus 1. Again, we're using each term represented once. Okay, now we want to find our new numerator. What did we multiply x squared plus 4x plus 3, which was in other words x plus 3 times x plus 1 by, to give me the new numerator? That would be x. So we multiply x times the numerator that was already there. Alright, what did we multiply x times x plus 1 by to give me x times x plus 3 times x plus 1? So that was x plus 3. So we have x plus 3 times the numerator that was already there, which is 1. Okay. Now we're going to distribute. Alright, so we have x times x, which gives me x squared. X times 2, which gives me 2x. 1 times x, which gives me x. And 1 times 3, which gives me 3. Now, notice that this is a minus sign, so both of these are going to be being subtracted. Alright, then we can combine like terms. We have 2x minus x, which gives me 1x. Nothing combines with the x squared. Nothing combines with the minus 3. So we're left with x squared plus x minus 3 over x times x plus 3 times x plus 1. Alright, I want you to go ahead and try this example on your own. We have x plus 2 over x plus 4 plus 6 over 1 plus 2 over x squared. Alright, go ahead and try this one on your own, and we will check it when we come back into class.